Okay, so we're going to be looking at how to use a factor to divide using polynomials. So basically this is called long division. So pause the video and you can kind of go back in and look at step 1 and 2, kind of decide on how did we get to the point we are at step 3. So what I want to do is I want to use the factor that I've chosen to divide with. In this case, it's x minus 2. I want to divide it into this problem, and it's a lot like dividing long division with just whole number values. We're going to focus on the very first part of the little binomial term we have. So I'm going to say, how many times does x go into 5x cubed? Or in other words, what do I multiply by x to get it to be 5x cubed? Well, the whole numbers are always easy. They're usually just the same thing. And then the x, since I'm multiplying by x, I'm going to reduce that power of x by 1. It's going to be 5x squared. Now what we're going to do is we're going to multiply this term up top by both of these two numbers. We're going to write them here and here underneath the cubes and the squared terms appropriately. So 5x squared times x gives me 5x cubed. And then 5x squared times negative 2 is negative 10x squared. Right? So that ends that part. We're going to subtract here. So when I subtract, I make it a point to subtract by adding the opposite. So I'm going to change all the signs that I'm working with so that I can remember to change the sign for both parts. So when we add these together, you get 0 for the first part, and that part should always end up being 0. If it's not 0, it means you did something wrong. And so we add the next part, you're going to get 8x squared. Then we're going to bring down the next number in the list, so minus 20x, and that resets us up to do the same thing again for this next part. I'm going to do it again. What times x is 8x squared, so plus 8x. And so we multiply that times x, we're going to get 8x squared here. Then we'll multiply that 8x here times the negative 2. We're going to write that right here. That's going to be negative 16x. Remember to change those signs and add them up. That's going to give you a negative 4x. I'm going to bring down that next term. And we'll keep doing this until I run out of terms to bring down. Now, since this is my last term, and since we've already plugged this into the original equation, and we know that the value that you get when I plug it in gives me 0, it means that when I do this last little subtraction, I should get 0. If I don't, I know that I've made some sort of mistake. So we're going to go back up. I'm going to multiply by negative 4 here. So negative 4 times x is going to be negative 4x, and negative 4 times negative 2 is positive 8. I should get the exact same thing. We're going to change our signs, and we're going to add them up, and that gets me 0. And that's just reaffirming that you did it right, because you already know that the remainder should be 0. If I had used 1, I would have gotten negative 9 in that part, right? We chose 2 because we knew that it was a factor. Okay, so now what we have here is we have a reduced equation. If you look at the top part of this fraction, or not fraction, this division part, I have what's a reduced equation. We started with a cubic equation, 5x cubed. Now we've reduced it to 5x squared. So 5x squared plus 8x minus 4. What I want to do, I've already determined that x equals 2 is a root, right, by plugging it in that way. And now I want to find the other roots. This is a cubic equation to start off with, so I know that there are 3 solutions to this problem. So I'm going to go ahead. Since I've got a quadratic equation, we have an x squared term as the largest exponent, so this is called a quadratic. I can use the quadratic equation to solve this. And so we're going to have that equation is x equals negative b plus or minus the square root of b squared minus 4ac. And that's all over 2a. So we're going to plug all that in. So x equals negative 8 plus or minus the square root of 64 minus 4 times 5 times negative 4. All that divided by 2 times a, which is 5.